Inadequate infrastructure is said to cost the UK at least £2 million a day. With ageing assets, leaky water pipes, potholed and congested roads, slow internet speeds, drafty buildings and extreme events, the health of the country's infrastructure has long been a concern. The UK's National Infrastructure Plan reinforces that delivering the right infrastructure at a local, regional and national level is key to the government's long-term economic plan. However, creating new infrastructure while maintaining the nation's existing one is a formidable challenge. Launched in 2017, the UK Collaboratorium for Research on Infrastructure and Cities, or UCRIC, provides leadership and support for an unparalleled national infrastructure research community. Working with 15 universities, UCRIC's interdisciplinary programmes integrate research on city and infrastructure design, construction, operation and performance. It is doing this through experiments, analysis, living labs and modelling, fostering a comprehensive approach to critical infrastructure. For example, UCRIC has been addressing the multifaceted issues faced by the nation's bridges. The controversy surrounding London's Hammersmith Bridge, which remains closed after the discovery of debilitating microfractures in the iron structure, is a poignant reminder of how important adequate investment in bridge maintenance, monitoring, renewal and design is, and how complicated it can be to find workable solutions. Recently, there has been an increased interest in integral bridges because of their potential benefits over bridge constructions that use bearings. Indeed, integral bridges have simpler maintenance requirements and reduced maintenance expenditure. However, their widespread use is being held back by critical gaps in scientific knowledge, which has led to expensive and risk-averse design practices. Uptake has been hampered by the need for longer spans and larger skews than current codes of practice allow, combined with uncertainty over high-speed rail interaction, seismic activity, daily and seasonal thermal loading, and lack of expertise, as well as the lack of validation through simulation modelling and large prototype-scale empirical evidence. Through a pilot project titled Priming Laboratory Experiments on Infrastructure and Urban Systems, or Plexus, UCRIC's researchers have been exploring the potential benefits of integral bridges by tackling these existing technical challenges and determining how integral bridges can provide other services, such as harvesting energy.
Breaking down barriers to implementation is key to reducing the over-design and costs that currently hold back innovation and prevent the nation from utilising new technologies and design approaches that would benefit everyone.
Researchers at the universities of Birmingham, Loughborough and Bristol led the Plexus team in taking a collaborative, transdisciplinary and learning-led approach to tackling the problems with integral bridges.
By establishing new collaborations in field testing, laboratory experiments and computer modelling, Plexus has laid the foundations for how engineers and other professionals can transform their approach to infrastructure research.
Researchers at the universities of Birmingham, Southampton and Bristol collaborated on physical laboratory tests to understand the impacts caused by changing temperature on bridge deck expansion and contraction.
These can cause the ground supporting the bridge to compact, which in turn causes stresses on the bridge that potentially affect its long-term performance, ultimately inhibiting wider use.
Researchers at the universities of Leeds and Manchester performed laboratory tests on 2 different types of concrete, fresh and carbonated, when subjected to extreme stresses caused by heat and impact loading.
The results were interesting. The concrete that was prepared with pure Portland cement showed an increase in strength and stiffness upon carbonation, while the concrete that was prepared with a blend of Portland cement and fly ash showed a slight reduction in both strength and stiffness upon carbonation.
Researchers at the universities of Cambridge, Cranfield, Leeds, Newcastle, Sheffield, and Imperial College London have demonstrated that it is possible to extract heat from existing infrastructure, such as integral bridges, a potential game changer that opens up new possibilities for other structures.
This capability creates new opportunities for decarbonisation, sustainability and reducing fuel poverty. Importantly, it could also be used to limit temperature variation in integral bridges and thus improve their structural performance.
Through its research, Plexus has demonstrated that the widespread adoption of integral bridges has huge potential for reducing bridge construction and maintenance costs, and for improving their long-term resilience. But perhaps more importantly, it has shown that it is vital to identify additional benefits alongside addressing the technical issues if infrastructure is to contribute to global priorities such as climate change.
This novel approach starts in the early design phase of a piece of infrastructure, considers contextual differences, measures value beyond money, considers future resilience, and aligns business and governance models accordingly. Only then can a robust and compelling case for change be made. And only then will the country's infrastructure truly enhance the health, well-being, sustainability, and resilience of the communities it serves.